the lab. And also, it needs to be wearable and wireless, so you have have a very good protocol for wireless transmission. So that's what we do. We created a 64-channel, up to 64-channel wireless synchronization data acquisition system, which is wearable. And you can see that the whole amplifier is just the size of the name card. And it's lightweight, compact, and flexible, and wearable design. And also it's robust and for ambulatory use in a very natural environment, as you can see. So we have been tested in various environments. As you can see, we have tested in the car. And during the driving, we have to deal with two kinds of environments. So in terms of the electromagnetic interference, we have to do a better job at shielding the devices, just like what we did with the dry electrodes. We also have a very good technology to shield out all those electromagnetic interference. As you can see from here, we are immune to line noises. You can see without any pre-processing of the data, you can see very clean spectrums from our devices. The second one is the motion artifact. So we compared our system with the state-of-the-art EEG systems while the subject is running on the treadmill. And as you can see, when we're doing the task, which is a BCI task, and by letter recognition, we have a higher recognition accuracy compared to a traditional EEG system while it's running. The reason behind it is two things. One is we're a compact system that can be all of those motion artifacts induced by those wires and those system movement can be minimized. And the second is we have all those motion artifact removal algorithms along with our 9-axis motion sensors to remove all those noises. And the third thing is wireless data transmission. So when we come up with wireless data transmission, the most annoying part is the data jitter. Not only just the data loss during the transmission, but also the data jitter. Why jitter matters? Because when we do all this research over with ERP, if the data jitters from the transmission, it will compromise the timing of the trigger so that we don't get very accurate triggering times. And actually, we have a patent technology to deal with it to make the trigger and the data perfectly aligned within 1 millisecond variation. And also, the data is perfectly aligned across multiple devices. So that enables us to do inter-brand ERP hyperscanning paradigm. So actually, this is the very first published ERP hyperscanning papers that we published on neuroimaging. It's a gangrene paradigm across different subjects. So they're sitting towards each other doing the gangrene task, and we could perfectly align those data together in order to get a very good ERP responsive processing. So not only just ERP, we can also do what we call collaborative BCI and gaming, which is what we do on the right side is we do a 5-subject synchronization, the measurements when they're doing video games, and also when we're doing BCIs. Also, we come from the lab that's specialized in BCI applications, so we provide tons of software and APIs for BCI applications, and these are what our customer controls robots and other things. So these are a few videos that you can see. We can control drums using combined with AR simulation in the drums, and we can control robotics. And feel free to try these out and ask us. And we do provide tons of standardized data sets and also online algorithms for you to accelerate all of your system integration along with your current robotics you have or other wheelchairs you have, so to build your BCI systems in real short time. Also, we held the biggest BCI competitions in China. Right now we have gathered more than 3,000 subjects of the data in doing traditional BCI paradigms, which includes multi-imagery, SSV, PM, and P300. So using this large data set, we can train our algorithms to have have last month we have the highest speed of the SSVP highest information transfer rate of the SSVP system built during this competition. They use deep learning algorithms along with all of the data sets we gathered. So this is a very efficient way to improve our PCI systems performance. So yeah, so welcome to check out all of our devices, and we not only just bring in those wireless EEG system, but we also have a very high density intracranial recording system, which has a 1024 channel EEG recording, spontaneous recorded at 32K sampling rate, and it's majorly for intracranial recordings and for epilepsy clinical studies, but also for electrophysiology studies. So welcome to check it out at our booth. Thank you.